Good morning. This is Tony Burbsky once again. It may not be morning to you, but it's 4:30 in the a.m. for me. Gonna lecture over 9.3 this morning. Um, find it a little more fun than doing my research today. So it's a good section. If you remember SOHCAHTOA, that's where we're going today. And I have my flipped over version called CHOSHACOW. So what we're going to do is review from yesterday, try to connect it to the where we're going today, and then should be all good. So recall, here we go. Let's see if we got the pen working. There we go. Struggling here. Recall, sine of theta was defined to be y over r. Cosine of theta was defined to be x over r, and tangent to be y over x. And then the three reciprocals, and its buddy, cosine's buddy secant, and tangent's reciprocal buddy cotangent. And we developed some cool observations with respect to the circle. So all we added was a radius and an angle, and these extra variables and interrelationships are supposed to create this oscillatory motion that we're looking for. But while we're discovering, we just automatically see that x squared plus y squared is r squared. Therefore, r is the square root of x squared plus y squared. We discovered that tangent of theta was also sine theta over cosine theta, and of course cotangent of theta is the reciprocal of that. Additionally, we discovered the three Pythagorean identities. One plus tangent squared equals secant squared theta. 1 plus cotangent squared theta equals CSC squared theta. I think that's about all we know, other than doing problems with these formulas. They're trying to get you to memorize them. You know what my suggestion is? You memorize them. Well, today it's kind of dumbing it down, make it a little more, I don't know, word would be mnemonic device, trying to make it a little easier. But trust me, you need to know everything that's on this page before me and know it cold, like maybe for the next 15 to 20 years. Anyway, moving on, let me get to today's stuff. So let's all draw. I don't know if you guys are drawing or not, but looking at some angle, and I'm drawing it exactly like this, where this is some point xy, and this is a radius. Therefore, this is y, and this is x, and this is theta. But with respect to theta, this is the opposite side. With respect to theta, obviously this is the hypotenuse. And with respect to theta, well, this is not opposite nor hypotenuse, so we call it adjacent. Adjacent just means side touching theta. That's not the hypotenuse. Anyway, this is abbreviated the HYP, the OPP, and the 80J. Now, we defined sine theta to be y over r, cosine theta to be x over r, and tangent theta to be y over x. But Let me see if I can adjust the view. View, zoom, 100%. That'll work here. So there's this mnemonic device. It's so ka to slash slash slash, and what it says, the S stands for sine theta equals the OPP over the HYP. But the opposite in this scenario is Y, and the hypotenuse is R. Oh, it's the same thing. Cosine theta is the ADJ over the HYP, which is X over R. And then finally, tangent theta is the TOA, the OPP over the adjacent, the ADJ, and the opposite with respect to my picture is Y, and the adjacent is X. See, nothing's the same. Now, this really only works for angles less than 90 degrees. So it's not as strong as our previous section, but what we'll do is basically we'll learn how to take the 4 quadrants and squish them into one. So technically it could work pretty much every time. Now, I promised you something different than SOHCAHTOA. You can add, here, let me rewrite SOHCAHTOA. SOHCAHTOA. Oopsie, that matters. I made this up, by the way. The reciprocal of sine is cosecant, CHO. Reciprocal of cosine is secant, SHA. And KO. Yeah, I know there's 2 C's. Who cares? It says CSC theta equals HYP over the OPP. Secant theta is hypotenuse over the ADJ, and cotangent theta is the ADJ over the OPP, also known as R over Y, R over X, X over Y, with respect to the picture above. Okay, next, what I'd like to do is remind you of your special right triangles. There's the 30, 60, 90. This is a geometry thing. The short side is 1, the long side is 2, and you need to start memorizing that the square root of 3 is about 1.73-ish. That'll surprisingly help you in this class. Anyway, it doesn't matter that you're set up here when you do SOHCAHTOA. It helps me because it helps me keep track of my X's, Y's, and R's, but you don't need it. So if I ask you sine 30, just put your eyeball right here, say opposite over hypotenuse. By the way, if I say the square root of 81, you yell out 9. It is advantageous to memorize that sine of 30 is 1/2. So sine 30, 1/2. Square root of 16, 4. Sine 30, 1/2. Kind of like that. All right. Now cosine 30 is adjacent, the ADJ over the HYP. And tangent, oops, I said 30. I was thinking ahead. Tangent of 30. Oopsie again. Tangent of 30 is opposite over adjacent, which you got to rationalize. Just get used to it. Now, if the square root of 3, by the way, is 1.73-ish, and then you divide it by 3, it's 0.57-ish. the square root of 3 over 3 is about 0.57. Once again, square root of 225, 15. Tangent 30, square root of 3 over 3, which is approximately 0.57. Don't worry, eventually you'll have to memorize stuff. It'll all fit together. That's your foundation of trade. Just giving you suggestions. You might want to memorize that fact. It is helpful. Now, you can just put your eye here, and you go sine of 60, and you say opposite over hypotenuse. Then they're like, well, sine of 60 is the same as cosine 30. Is there some type of relationship there? Perhaps. Now, we can go cosecant 60, and you say cho, so you say hyp over the opposite. Cho, h over o. The hypotenuse is 2, and the opposite is 1. But, 60. Okay, get on to 60. Hypotenuse is 2, and the opposite is the square root of 3, which you got to rationalize. Now I'm not going to do the rest of them. So there's your special right triangle. Get it back down. Hey, I should mention this. Some people learned it 1x, 2x, the square root of 3x. So if you go times 3, you get 3 radical 3, 6. They're similar, and you can use this idea of a ratio to create kind of anyone that's given to you. It's more important to go from here back to here. So if you see the 6 and you got you got a 30, 60, 90, what you do is you look at the 2 and you go 6 divided by 3 is 2, check the other ones, because 3 divided by 3 is 1, and 3 square root of 3 divided by 3 is the square root of 3. So if all 3 checked, then you know it's similar, and then you can use what you know about 30, 60, 90. Moving on. The 1, 1, square root of 2. And then also known as the 1x, 1x, square root of 2x. These are 45s. So if I go secant 45 degrees, I say Shah, so it's hypotenuse over the ADJ. Hypotenuse is the square root of 2. I'm looking here, adjacent is 1, therefore square root of 2. If I ask you a question like cosine 45, you know it's reciprocal of secant. You could have said ka, but I say reciprocal 1 over radical 2. But you can't leave a radical in the denominator, so you got to multiply by radical 2 over 2, straight across, radical 2, square root of 4, 2, boom. My favorite is tangent 45, because it's TOA, which is OPP over the ADJ, but they're both 1. Therefore, cotangent 45 is also my favorite. Also get 1. Sorry about the pause there. Give me a second here. Okay, so basically you should be able to do 30 and 60 degree anything. What I'm trying to say is basically you should do tangent 30, cosine 30, secant 30. It doesn't matter. You need to know your 30s and your 60s. So there's a table in the book. I'm anti-table. I'm more of a SOHCAHTOA, know your right triangle type of guy, and just keep doing it till you actually get it down. If you forget it, You got your special right triangle, your little SOHCAHTOA, CHOA-CHOA-COW, you always know it. Memorizing the table, it's done me no good. Then again, if you're doing your homework and you have a copy of the table there, it makes it faster. I don't personally think it helps you. Better go slow than fast. Anyway, they got this obsession in this text with this identities called the co-function identities. Once again, I introduced the graphs the other day. The graphs help explain it better, but even I have a little difficulty explaining it in this section, so I'm going to just wimp out and just give you the identities. They say you're supposed to figure out that sine of 90 minus theta equals cosine theta, meaning just a little bit ago we looked at sine 30. So if theta equals 60 degrees, we get sine 30 via the formula equals cosine 60. We realize that, but if theta equals 30, we get sine 60 equals cosine 30. And these are all degrees. We get lazy. So if theta equals 10, sine 80 degrees, by the way, I don't know what sine 80 degrees is. It's like the square root of 19. I have no clue. But it does equal cosine 10, etc. It's crazy, but true. Now, if I had the graph out, I could like shift it, flip it, and totally explain it, but we're not quite there yet. I have to introduce what's even and odd. Anyway, we get this relationships that work with all the functions. Because they're similar, the graphs are similar, you can shift them and flip them and make the same. And it's always like a 90-degree shift flip. So, here's all six. Sine of 90 minus theta equals cosine theta. Cosine 90 minus theta equals sine theta. And let's bust them out. Tangent 90 minus theta equals cotangent theta. Cotangent 90 minus theta equals tangent theta. CSC 90 minus theta equals SEC, like conference theta. SEC 90 minus theta equals CSC theta. And don't forget to use degree. There's this one, there's one, put an extra one in somewhere, don't care. Alright, so, once again, so secant of 10 degrees equals cosecant of 90 minus 10 degrees, which equals CSC 80 degrees. So they think that's a good identity. When I grew up, we didn't talk about it much, so I don't see why they're so obsessed with it in this book, but we'll play their game. And trust me, in MML, they do play games with this, and probably best for me to find a problem or two in your reading so you don't fall down that hole. It's like a trick. It's like a trick, Sudoku-like problem. Anyway, here we go. I need to introduce something called reference angle here in a second. Okay, let's do that reference angle thing. Now, reference angle is really trivial concept, so I'm not going to use the blue box in the book. I'm going to just say reference angle, do some examples, and call it a day. Alright, so basically a reference angle, so a reference angle, so ref angle, I abbreviate it, theta sub ref, is bounded between terminal side x-axis, that's lazy, x-axis and theta is between 0 and 90 degrees. By the way, theta is between 0 radians and pi over 2 rad. And you don't write anything rad. Anyway, so let's not do the stupid case. Let's start you out in the second quadrant at theta being 120 degrees. Well, here's the terminal side, and there's two places to look. Here's an x-axis, that's the minus axis, and here's the plus axis. So you got two choices. You look in here, you got a 60 degree angle, or you got a 120 degree angle. Theta ref is less than 90. So theta ref, 60 degrees, it's that angle right there, 60 degrees. Now, it's not actually that angle. The angle we're talking about is in the first quadrant. It's 60 degrees, the reference angle. So it's definitely in the first quadrant. It just looks like it's there. Anyway, let's do more. You know, right here, 210. So you got a choice. Terminal side. The negative axis, whoops, let's not use black, and the positive axis. So the only two answers would be 30 and 210. Therefore, we'll go with 30. If someone gives you 280, you know this is 10 degrees, so therefore this is 80 degrees. So you got a choice, 80 or 100. Go with the one less than 90. Theta ref is 80 degrees. And finally, the stupid case. If theta equals 25 degrees, you got a choice. Pick 25 or pick 155. So theta is actually equal to theta ref. Alright, that's all I got for you. There's reference angles. Now, let's evaluate some angles to create a reference angle method. So what I want to concentrate on is 30 degrees. But I want to put the special right triangle, the 1, the 2, the square root of 3, right there. But I also want to add another one, so let's do it in a different color, right there. So this is 1, this is 2, and basically this is negative root 3. So let's start writing points. So it's negative root 3, 1. This is root 3, 1. But yet, let's do it again. And you get the point negative root 3, negative 1. Keep in mind 30 degrees, 150 degrees, 210 degrees, and why not? We're almost out of colors. Not really. Probably got 256 more. We get the square root of 3, negative 1. Remember, x, y, x, y, x, y, x, y. So I manually can do sine of 30, sine of 150, sine 210, sine 330. No problem. Sine of 30 is y over r. Sine 150 is y over r. Sine 210 is y over r. Sine 330 is y over r. Now, that's, I don't know if you want to call it slow, but it sure works. recall all students take calculus. Since I'm concentrating on sine, they're all positive. Sine's positive, and then sine goes negative, negative. So I'm talking about sine here. So in the first quadrant, sine is positive. In the second quadrant, 150 is in the second, sine is positive. In the third quadrant, like 210s in the third, sine is negative. And in the fourth quadrant, sine is negative again, and this is in the fourth quadrant, so it's negative. Kind of funny how it all makes sense. But here's the deal. Sine 30, reference angle 30. Sine 150, reference angle 30. Sine 210, reference angle 30. Sine 330, reference angle 30. And they all equal to 1/2 except for the plus or minuses. So if I have sine 150, how about square box sine reference angle? Reference angle is 30. But what quadrant are you in? Well, we're talking about sine, all students. Sine, we know the answer is positive no matter what. And I know sine 30 by memory, 1/2. Boom. So cosine, oops, that's not cosine, I'm on a sine roll here. So sine 210, I could think I'm in the third quadrant, but why not just say negative? And what's the sign of the reference angle? What I'm doing is taking the second, third, and fourth and push them into first. So basically, I can use SOHCAHTOA, but let's do it again. Sine 330 equals square box sine of the reference angle. And we know sine is negative in the fourth. And once again, it doesn't make any sense because the reference angle in the first quadrant is the angle itself. So, here's my conclusion. I conclude that trig of theta, any of the six, equals square box, insert a plus or a minus, trig theta ref. So it just doesn't matter. So let's try tangent 300. I'm here in the fourth. All students take calculus. I'm talking about tangent. They're all positive, tangents positive, negative, negative. Therefore, negative tangent, but what's the reference angle? 60. Negative tangent 60. Now I know that's the square root of 3. Why? Well, I'm old. You are stuck with this. Make sure you tip it up right. And you say TOA, so the square root of 3 over 1. Boom. Done. Reference angle method. Now, let's try secant 210 equals square box secant 30. There's 210s here, reference angle 30. All students take calculus, cosine, and secant have the same sign chart. So plus plus, minus minus, I know 2 10s in the third, so negative. Now secant 30, as soon as you get them memorized, you're set. Since you don't have it memorized, you say Sha, then you draw your special right triangle, and then you say hypotenuse over adjacent, -2 over radical 3, but you can't leave the radical in the denominator in this class, and sorry for running out of space, -2 radical 3 over 3. Sha works great. So just know, that since things are moving so fast, most people become reference angle math people. But unfortunately, we're going to introduce the unit circle, which once again is the whole circle. So we're going to kind of be working, hey, it's okay to use the whole circle with x, y's, and r's. Hey, there's this reference angle method. And by the way, we're going to introduce the unit circle. So you're going to have like 3 different ways to do it. It's best to know all ways. I always look at it like this. I got a nail to pound in. It's in their corner. Very difficult, by the way. Would you like to have one method to pound the nail in? Or would you like to have 7? Trust me, 7 is way better than 1. It's very frustrating if you only got one way. So I like multiple ways. It's always a good thing to know that more than one way, because there's certain problems that kind of how do you want to put it? Certain problems that one of the 3 methods is better, so you try to choose that method. And if you get bored, you can always work it 2 different ways. Okay, let me see what else is in here. Finding angle measures using your calculator. Are you kidding me? Oh, no. Okay, here we go. So it's like working backwards. They want to know, when does sine theta equal 1/2? Well, I'm the visual guy. By the way, we're not supposed to have the graphs, but I gave them to you anyway. Sine theta. Now this graph goes forever. This is 360, i.e. 2 pi. I'm a radian guy. Pi, 90, pi over 2, 180. See how I go back and forth? I don't even feel it anymore. Now, when does the sine graph equal the horizontal line? 1/2. That's the worst 1/2 ever. Well, to do a better one, I can see that 30 is most likely my answer, and probably 150. Besides that, I ask you to memorize sine of 30, 1/2. So I know the angle I'm talking about is 30 degrees. But sine, all students take calculus. Here we go. Sine is plus plus, minus minus. So when is sine theta equal to something positive? Well, that'll be in the first quadrant and the second quadrant and the associated reference angle. So yes, I know sine of 30 is 1/2, but also can't forget the reference angle. Sine of 150 is also 1/2. That's probably the best I ever explained in my entire life. Why I never did that, I don't know. Too bad I did it super fast and messy, so let me try another one. This is kind of fun. Okay. By the way, you're not supposed to see the visual. So you know how much harder that would be if you didn't have that? Anyway, let's give her a shot again. I'm going to try one like, when does tangent theta equal -1? Now, I know tangent, all students take, they're all positive. Tangent theta. Negative means I'm here or here. Now, it's all about the reference angle, so there's one, and there's the exact same one. So we just got to figure out basically when tangent is -1. So I got tangent theta equals plus or minus tangent theta ref. So we know we're at minus. So all we do is have to find this reference angle. Now, and this guy's in the first quadrant, so you got to refocus your mind, and we're looking here. Now, you only know your 30, your 45, and your 60. That's all you know. And your 0, and your 90. You can do 0, 90, 30, 45, 60, so it better be one of those three. So you got your special right triangles, 1, 1, the square root of 2, and the one that works is the TOA, which is 1 over 1, which is 1. So I know the angle I'm talking about is 45, but it's the reference angle. So I'm in the second, where this is 45. I'm in the fourth, where this is 45. Therefore, my answers are 135 and 315. Because the original question is, what angle am I talking about? Now, this is pretty tough in this section because you're like working with like a third of your tools. It's a really tough question. Now, the book makes it worse because they go, when does cosine theta equal 0.8, which is 4/5. I only know special right triangle stuff, and I'm telling you what, my special right triangles, there's no way with 1s, 2s, square root of 3, square root of 2s, I'm going to get 0.8. But you say it anyway. All students take calculus. It's positive, so I get two answers, one here, one with the exact same reference angle, one there. Now, I need to figure out the reference angle. Now, we don't even do inverses for a while, like what is an inverse, but they assume right away you know how to do inverses, so here we go. When does cosine theta equal 0.8? Now, what do you do to both sides? You take inverse cosine. You take inverse cosine. Now, the inverses cancel each other out, and you get theta equals inverse cosine of 0.8. You, even though I say you're radian people, you better be working in degrees. Mode, get out of radians, switch to degrees. Second quit, second inverse cosine, 0.8, boom, boom. I get 36.869 degrees. So that is one of my answers, because I am in the first quadrant, but the other answer is 360 minus 36.869 minus 360. And the answer is 323.130 degrees. Now, I feel weird doing this at this time because it's pretty early in the chapter for all this, and there's a lot more to explain, but the book, they go after you a little bit, and they do assume that you know how to do inverse cosine. So the worst thing ever would be to be doing MML, and somebody didn't talk about it. So it's kind of where we're at. Now, you could have worked the last problem in radians, by the way. I see something at the tail end. So what I always do is I work the problem in degrees, and then I know there's two answers. So you see how I went 360 minus 36? So theta and radians, so you switch your mode to radians, second quit. Now I do inverse cosine 0.8, and that's my radian angle in the first quadrant. Do I understand it? Well, no, I'm not used to working in radians. I've been only doing it for 30 years, well, actually more than that. Anyway, you're not supposed to have a good feeling for what 0.64 radians are right now. But you know what I did with the second one? I went 360 minus that answer, so I got to go 2 pi minus this answer. 2 pi minus that answer. Enter. 5.639 radians. So I got 2 answers. First quadrant, fourth quadrant. Do I know that's in the fourth quadrant? Well, kind of, but you guys know. But that's kind of how the game is played. Cheat in degrees when you're doing inverse anything. Get understanding what your answers are. Then turn around and redo it in radians, and you'll be all good. Well, I'm looking in the book, and it says I'm done with my lecture. Plus, I got to cook breakfast, so I'm going to stop right there.